So we learned back in chapter 7, how much does p hat bounce around above and below its true value? Sigma of p hat, the standard deviation of p hat. And we learned that that's the square root of p times q over n. And I can't calculate that. And the reason that I can't calculate that is because I don't know the true value of p. If I knew the true value of p, I would not have done this experiment in the first place. Or you would not have gone out and taken the survey in the first place if you knew in the entire population what proportion of people think that Governor Newsom's doing a good job, or what proportion of the time the thumbtack will land in the safe position. We don't know that. That's why we're doing this experiment in the first place. I'm going to use the next best thing I've got, and I'm going to call it S with a standard deviation of p hat. And it's very similar. It's just going to be p hat times q hat over n. So same thing, except I can't use my desired p and q. I've got to use my estimates, p hat and q hat, because that's all I've got. So this is going to be the square root of 0.695 times 0.305 over 800. And I will get S of p hat is, throw that into the calculator. I'll do the same, so hopefully I'm giving you enough time here to do this on your calculator. Pause the tape if you have to. But I got the square root of 0.695 times 0.305 divided by 800. Close the parentheses, and I am getting, at this point, you usually get an ugly decimal, and it's better to keep around a few too many decimal places rather than too few, causing rounding error. So don't round this off to 0.016 by any means. I'm going to keep around a few more and call it 0.016278. It's got 78 here on my calculator, 778, but I'm going to round it a little bit. But again, don't chop it off too soon. When in doubt, keep around for the calculation purposes more decimal places instead of fewer. All right. Now, again, this is the size, my estimate, or at least the size of the standard deviation, but we think we're going to say, you know, I might be off by as many as 2 standard deviations. So I'm going to have 2 times S of p hat, which is 2 times 0.016278, my error estimate. And now I can round off to as many decimal places I had, or maybe one more. It's going to be 0.0325 or 0.023. This is actually going to be closer to 6. It'll be close, but okay. So that is my error estimate. And now I'm not just giving you an interval estimate. I am saying that my 95% confidence interval for P is P hat plus or minus this error. It's 0.695 plus or minus 0.0326, which is 0.6624 up to 0.7276. This does not guarantee me that if I repeat this experiment, I'm going to land in that interval 95% of the time. That's not what this is saying. Let's think about what we were trying to do. We're trying to estimate P, trying to estimate the true proportion of the time that a thumbtack lands in the safe position, or the true probability that a thumbtack lands in the safe position. And we'll never know P for sure. But what we are saying is, I'm pretty sure, and by pretty sure, we're saying I'm 95% confident that P is somewhere inside this interval. Okay, so I don't know the true value of P, but I'm pretty sure, and again, I'm quantifying what I mean by pretty sure. I'm 95% confident that P falls somewhere inside this interval.